Okay, so we're going to learn how to solve the 2003 Calculus FRQ question number 1. And the first thing you want to do before you start anything, before you even pick up your pencil, is read the question carefully. And in this one, the description says, let R, right here, be the shaded region bounded by the graphs of y equals square root of x and y equals e to the negative 3x. And the vertical line x equals 1 is also part of it. First question, question A, says find the area of R. Now, before you start anything, you have to get an understanding of what they're asking when they say find the area. One, you know when they say area that you're going to have to use integrals because you want to find the area under the curve. And you also want to understand how to find that. So one way to do it would be to use the integrals and say the integral of y equals square root of x minus the integral of e to the negative 3x. But of course you have to determine your bounds. So the way we're going to solve this is we're going to first, you have to find the bounds here. You have to find this x value so that you know when you have your integral from a to b, you have to find what this is. And you know that b is 1 because they give you the vertical line of x equals 1. So in order to find a, you're going to have to use a calculator. And questions 1 through 3 let you use a calculator. So we're going to set these equations equal to each other in order to find that point at A in which they intersect, right there. But you only need the x value, you don't need the point. So if you set these equal to each other, you can use a calculator to solve this, of course. That's going to be the easiest way. And there's a couple different ways you can do it. You can graph it, and you can use your calculator to trace and find the exact point of intersection, or you can use a solver and plug that in that way. I'm going to graph it so that we can see it visually. Okay, so now that you have your graph set up, you're going to want to go to Calc, and then go to Intersect, and then you use your arrows to estimate the point of intersection, and there it is. It gives you the exact intersection points. So we know that that x value, let's call that A, is 0.2387 about. So I'm going to write that here. So that's going to be our first bounds for our integral. Alright, so next we're going to use the bounds that we discovered, so now we know what A is, to set up our integral to find the area. So A, about 0.2387 to 1 is our bounds, and then the integral is going to be the square root of x, so all of this, minus e to the negative 3x, which is this part of it. So that's going to give us that, the area of R, dx. Okay, so now that we have our integral set up with our bounds and everything, it's going to be really easy to plug it into a calculator. So I'm going to go ahead and show you how to do that. So you're going to want to go to Math, Integral, and then you're just going to plug everything in. So 0.2387 to 1. And it's going to be the square root of x minus e to the minus 3x. And of course, that's dx. And there you go. You got an answer. So on the AP test, you're going to want to round to 3 decimal places. So this is going to be 0.443. Okay, part B says find the volume of the solid generated when R is revolved about the horizontal line y equals 1. So in order to do this, we know that the volume of the solid generated is going to require pi r squared of something. And what we want to find is r, because we know that we have to find the radius. So we have to find the radius of this minus the radius of the part that we want to hollow out. So there's also a formula that you can use, and it'd be the line that you are revolving it around. So that number minus the far equation, and then minus the quantity of 1 minus the near equation, and both of those would be squared. In order to do that, we're going to use the same bounds, and of course this is all going to be dx still because this is a horizontal line. If we were revolving it around here, we'd have to change our equations with respect to x. So it's going to be from a to 1, and we're going to go 1, so all of that minus the far one squared, so e to the negative 3x squared, minus 1 minus the near one right here, closest to 1 squared, and then all of that is dx. So we set up our r squared, but you have to be careful not to forget the pi right here, because that's going to give you the volume of the solid given the radii. And once you plug that into your calculator, you should get 1.423 once you plug it in. And then that's your answer for part B. Another thing to keep in mind when you're doing these FRQs, especially on the calculator section, is that each little thing that you do, making sure that your bounds are accurate, having the pi, having the 1 minus in both things, those are each going to count for a point on their own, and they all add up. So you want to make sure that you don't make any errors with constants or switching things, like if these were switched, because these are all going to count for a point, and it all adds up on the AP test. Okay, so part C says the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a rectangle whose height is 5 times the length of its base in region R. Find the volume of this solid. So first we know that the cross-sections are coming out of the base, region R, and we know that the formula for a cross-section with a rectangle would be the side times the side squared. So whatever it is, the volume, I'm going to say V, is going to be the integral from that point, 0.2387 to 1, and then it's going to be s squared, right? But since it's a rectangle, we know that the base is going to be along R, so that's whatever region, the area of region R is, so that's going to be square root of x minus e to the negative 3x. But then the height, so that's what comes out, that's what pops out of region R, essentially, is 5 times that. So what we're going to have is this, let's call this u times the height, which is going to be 5u. So the volume of this cross-section is going to be u times 5u. So then you're going to get 5u squared. And that u is going to be the area of region R. So when you're setting up your cross-section, your integral, it's going to be the integral from that point here of intersection, 0.2387 about, to 1, that's right there, and it's going to be 5 times that area, which is e to the negative 3x squared. Not the 5 squared, just this part squared. Because this is part of the side, because we had already determined that it's 5u squared for the area, for the volume, of that cross section, because it's a rectangle with the height of 5 times. So that's going to be dx, and then you can plug that into your calculator and solve. Okay, so once again, you're going to need your calculator to plug this in. So square root of x, and I already set up that integral to the correct bounds, and then that whole quantity is going to be squared, and of course that's dx, and then you get 1.554.